Alrighty, section 5.4. We are moving along quite quickly with this chapter. This chapter is all about multiplying polynomials. So we finally come to that day where we are multiplying polynomials. We're going to be using a lot of those exponent rules. So hopefully you remember all the way back to 5.1 about those exponent rules. Now remember, last time in 5.3 we talked about something called composition of polynomials and composition functions, right? That was where we plugged one inside the other. That is not multiplying polynomials, and be careful of the two because people often confuse them together. What we are talking about today is multiplication of polynomials, okay? So it's the actual multiplication. Let's go ahead and start with multiplying just two terms, right? So just two terms. We can use the commutative and the associative property. We saw this way back when in section 5.1 when we were learning about product rule and how they were convened together. But so we had something similar to this problem right here. 3x to the fourth times 5x to the third. We've got two monomials, right? Monomials are a single term. These are monomials. Oops. Yep, no, that's right. Monomials. And when you multiply two monomials together, you don't have to worry about the addition or subtraction getting in the way because there is no addition of subtraction, right? So we can just use commutative and associative to rearrange it. So we can rearrange all the numbers in front, all the variables at the back, and then use that product rule to add the exponents together to achieve 15x plus 7. Something else you want to be careful about. Last time we talked about like terms, right? You do not need to multiply terms that are alike. I mean, you can, you're more than welcome to, but it's not necessary for them to be like terms in order for you to multiply. Again, addition and subtraction kind of throw us for a loop when we're dealing with polynomials, and that's where we have to have those special alike things. Here, you can multiply anything you want because it goes straight back to those exponent rules and that product rule, okay? So let's try another one out. We'll try out these two monomials. We've got negative 4a cubed times 3a to the fifth. And I know we've got some parentheses set up here, but even so, we know it's all multiplication, so we can rewrite this as negative 4 times a cubed times 3 times a to the fifth. Now we can use that commutative property where we rearrange stuff, right? Commutative means I can switch it around any order I want, right? So I can rearrange it as negative 4 times 3 and a cubed times a to the fifth. So I put the variables together and I put the numbers together. And then I can simplify that down. I'll go over here. Negative 4 times 3, negative 12. I'll use the product rule on these second two. So a to the third times a to the fifth is a to the 3 times 5, or sorry, a to the 3 plus 5, or a to the eighth. And we have our multiplication, our product, negative 12 a to the eighth. Awesome. And we can do the same thing for the second one, even with multiple terms. Commutative property works, I'm sorry, not multiple terms. Even with multiple variables, commutative property works for anything, right? So I'm going to let you guys try this one out. Go ahead and try it and make sure you've got this idea down, and then we'll do it in just a sec. Alright, so I hope you've had a chance to try this one out. But let's do it together. So I've got some numbers, I've got some m's, and I've got some z's. I've got some numbers, m's, and z's. So let's rearrange it, right? We've got 2 times 8, put the numbers together, times m squared times m cubed. That's just a multiplication sign in the middle there. And then on the end we've got z to the fourth and z squared. And they're still all being multiplied. Notice that when I rearrange them, I'm still multiplying everything together. Things don't just suddenly change to addition or change to subtraction or anything like that. But now I can simplify. 2 times 8 is 16. Product rule on the m's, right? I have to have the same base. I can't product rule all of them, but they have to have the same base. Just combine the m's, get m to the fifth, and then z to the eighth. And I have my multiplication of two monomials. Alright, so it's very important. Do not product rule all of them together. Product rule only the ones that have the same base. Okie dokie. Multiplying other polynomials. Let's talk about that. So sometimes we have something called scalar multiplication. If you remember from chapter 4, scalar just means you multiply in a number, right? So all you're doing is multiplying in a simple number. Why it gets its own name mostly dealt with last chapter, right? When we were doing it to matrix, it was a lot different from then multiplying a matrix by a matrix. However, when you're multiplying a scalar into a polynomial, it's no different than what we just did with it's no different than distribution property. That's all it is distribution property. Whether it's a scalar or a monomial or a binomial or anything later on, really all this boils down to is distribution property. That's pretty much it. But just know that scalar here means the same thing as when we did it with a matrix, okay? It just means that you're multiplying by a single number or a single term. Alrighty, so let's try that out. I believe most of you remember the distribution property from last time when we multiply things in. So we just take that -2, we multiply it to each of them, right? So -2 times -8 cubed, because -16 cubed, x cubed. -8 times -9x squared becomes a positive, right? Negative times negative is a positive. 18x squared. I have no variable here to change anything, so really I'm just multiplying those coefficients. And we have our new binomial of degree 3. Binomial of degree 3, right? Degree means highest power. Binomial means 2 terms. Awesome. Let's do the same thing with a monomial now. Instead of a scalar number, just a monomial. But again, distribution property. That's all this boils down to. So let's distribute that guy in. And notice I have a monomial times a trinomial now, so I have to multiply to all three. Multiply it into all 3. So I've got 5x squared times -4x squared. That would be my first multiplication. My second one is going to be 5x squared times 3x. That's my second one. And my third one is going to be 5x times -2. So I really haven't done any multiplication yet. I've just showed you how I'm distributing this out. And notice in between each one, I drew a little plus sign, right? So in between each monomial, I drew a plus sign, just as I did up here when it ended up being plus 18. Now let's actually combine those. Now I've got 3 different cases of what we did last time, monomial times a monomial. So we've got 3 cases of that. Let's go ahead and do that. So we'll start with this first one. Can rearrange it a little bit. Got 5 times 4 and x squared times x squared. That gives me, I'm actually going to cut into C just a little bit here, 20, and then I add those 2 together, x to the 4th will be my first term, right? It's my first term. I'll do it again for the second term, right? Do it again for the second term. I have 5x squared times 3x. I'll rearrange that just a little bit to have 5 times 3 times x squared times x. Even though they're unlike terms, I'm multiplying, right? So since it's all multiplication, I can multiply anything I want to. It doesn't matter about like terms. I have 15, and I'll add those together, x cubed. Fabulous. And then in the last one, I can still use the same idea here, even though this -2 doesn't have a variable. I'm sorry, this is an x squared, first off. X squared. Even though this last one doesn't have a variable, that's okay. I can still use commutative property. So 5 times -2 times x squared gives me a -10x squared. And I have arrived at my new polynomial of degree 4, my trinomial of degree 4. And I totally just crossed out the 4, but that's okay. Alrighty, hopefully this is making sense to you. Let's try one more out. You guys give it a try. Try multiplying this monomial by this binomial. See what you end up with. Okay, so hopefully you've had some time to pause the video. And hopefully you tried it out. And when you did, I hope you distributed that 4c cubed into the 5c squared and into the 3. And what you got was 4c cubed times 5c squared plus 4c cubed times 3. Notice each one got a 4c cubed. That's the idea here. Everybody gets a fair ticket or gets a piece of the game or whatever, however you want to remember it. But everybody gets to be multiplied by the monomial. And when we do that, we can rearrange this guy. We end up getting 4 times 5, which is 20. C cubed times c squared, you add them together, you get c to the 5th. Second one here only has one variable, which is okay, but same concept, right? I'll multiply the numbers, which gives me a plus 12. plus 12. And since I don't have any more c's, I'll just tack on the c cubed that I have. I get 20c to the 5th plus 12c cubed is my answer. Alright, the entire rest of the lesson today stems from this idea right here, this distribution idea. So if you have any questions, whether it's about the actual distribution part or the combining the monomials part, please, please, please pause the video now and talk about it. Discuss things that you didn't see or that you didn't understand, things that were problems, because the entire rest of the day develops off this concept. So, alrighty, hope you had time to talk about it. Now we're going to multiply things that are slightly bigger, some binomials times a binomial, some binomials times trinomials. However, over the years, you have probably heard many different organizational methods on how to multiply polynomials, whether you've heard of FOIL, the box method, a vertical graph, or a vertical table, whatever it is. Use whatever you like, okay? So if you remember FOIL and you want to use FOIL, go for it. If you remember the box method and that's like the only way you've been ever able to figure this out, please continue to do so. I do not want to make you learn a certain method for this, because no matter what method you're doing, it is still just distribution property. All of those different methods, quote unquote, are just organizational methods. That's all they are. It's a way to organize your thoughts, okay? So whatever way to organize your thoughts you've already got going, please keep using it. Do not stop using it, okay? Because I don't want to mess that up. But if you have no organizational method yet, maybe this was something that never really kind of clicked for you, or you are always kind of like jumbling stuff around and maybe you happen to get it done, that's totally fine. You can use my organizational method, or you can use something that one of your friends teaches you. It's totally fine. But every single method is all about the distribution property. That's all it is, okay? When you are multiplying larger polynomials, what you're doing is taking the polynomial and breaking it down into monomials and then doing as however many cases you need of what we just did, okay? So let's take a look at this one right here. I've got this nice trinomial, right? 3 terms being multiplied by this binomial. I'm actually going to use some different colors to illustrate this point. Multiplied by this binomial, okay? What the idea is let's take every single term in the trinomial, every single term in the red, and multiply it by every single term in the binomial, or in every single pink term. And that's what they've done here. Notice they take the red, and they multiply, they break it up into the 3 terms, right? Break it up into 3 terms. And then they multiply it by the pink every single time. And even within there, you multiply term by term, right? So this first one became here, second one got there, right? Then you do it again for this one. Multiply, distribute. Distribute, distribute. So essentially you're just doing a whole a bunch of cases of distribution property. That's all it is. No matter your sizes. It could be trinomial, binomial. It could be binomial, binomial. It could be trinomial, trinomial. It could be a term of, or a polynomial of like 15 terms times a polynomial of 20 terms. All you have to do is make sure that you multiply every term in the first one by every term in the second one. Once you do that, you get a nice big string of polynomials, right? Oh, sorry, a string of monomials, like so. Let's use blue because it's a new thing. Purple. So you get a string of monomials that you add together, and you use combined like terms, and that's it. So really, all multiplication of polynomials boils down to distribution property and then combined like terms. That's it. Distribution property, combined like terms. So let's try that out. Let's try it out for ourselves. We've got this binomial times this binomial, right? I'm going to break this apart into, I'm going to break the first one apart into monomials. Okay, so I'm going to break it into 5a, oops, that's a horrible 5, 5a and 3, no, not 3, 2b, negative 2b. So I broke it apart into 2 monomials. And I'm going to multiply each of those monomials by the second binomial. So I'm going to multiply each of those guys by 3a plus b. Or in other words, I'm going to multiply each one of those to 3a plus b. Sweet. Now I'll just break those apart. So 5a times 3a, you get 5a times 3a plus 5a times b. Okay, cool. That's like the same thing we just did in the last chapter, right? 4c, or not last chapter, just the last section. Broke that apart, right? So let's simplify that down a little bit. I don't know why I keep switching colors, but why not? I've got 5 times 3 times a, which gives me 15a squared. Cool. Do the second one. 5 times a times b. Nothing really to simplify there, so 5ab is my second one. Thumbs up. Cool. Sounds good. Let's go do the exact same thing for the other monomial. Let's do the exact same thing. Do this one in green. Negative 2b times 3a. So we'll do plus a negative 2b times 3a. And a negative 2b times b. So plus a negative 2b times b. Go ahead and simplify those. We've got negative 2b, oops, sorry, not negative 2b. We want to do negative 2 times 3, an a, and a b. Can't simplify the a and the b, right, because those are on like bases, right? It's not like it's a to the first times a to the second. It's a times b. That's apples and bananas. I can't combine apples and bananas as much as I want to, because would that be an appa-banana? App-banana? An app-banana actually sounds kind of good. But, so if you figure that out, let me know. But in this case, I cannot combine apples and bananas, so I just get a negative 6ab. Yeah, if you haven't noticed by now, usually my thoughts tend to train away. So sometimes I like to pull myself back. Sometimes they go very far. Anyways, in the last one, I have negative 2 times b. Not much else to combine with the negative 2, but I get negative 2b squared. Alrighty. And that was the second monomial, right? Second monomial. Now I've got this string of monomials here, and I just look to see if I have anything that I could combine. Well, I don't have any more a squareds, so my a squared will stay the same, 15a squared. I have 2 ab's, right? They are exactly the same. They both have degree 1, and they've got an a and they've got a b, so they are like terms. I can add those together and get a minus ab. And then I'd only have one term left, so there's obviously nothing else to combine it to. I've got 15a squared minus ab minus 2b squared. And that is my multiplication of the two binomials. I'm actually going to go write that over here because I have to erase that in a sec. A squared minus ab minus 2b squared. That's my product. Cool. So notice it was no different than we just multiplied by a monomial. We just happened to do it twice because there were two of them. That's it. That's all it is, okay? So if you think you've got distribution property down and you love distribution property, this entire section should be very easy for you because it's just distribution property and combining like terms. Let's try one a little bit larger, just a little bit larger. It's a trinomial times a binomial, but as we just saw, it don't matter. It don't matter at all. We can just multiply each one as if they were a monomial. So let's go ahead and do that. Just give myself room, see how much room I have here. So I'm going to call it a purple. Do it in purple. So I've got the 3m cubed times the other binomial, 3m minus 5. And then I'll do the second monomial, minus 2m squared, plus the 3m minus 5. And then I'll do the 4, the last monomial, quote unquote. I guess it's a scalar, but you could call it a monomial, right? A monomial of m equal m to the 0, right? You could do that, but that's up to you. M minus 3m minus 5. All right, so I've just distributed it out. Cool, cool. Now let's tackle each one individually. Each one individually. So I've got this first one, 3m cubed times 3m plus 3m times minus 5. Now if by this point you can do this red stuff in your head and you can skip writing it out like this, that's totally fine with me. It's totally fine. But if you are still kind of where I am, I've never been a visual person. I always have to have things on paper in front of me. I've never been able to just compute stuff in my head. So I like to write it out like this. I like to take my time and say, okay, here's the first distribution, here's the second distribution. If you can do that part in your head, then that's fine. But if you're like me and you want to write it out, I highly recommend it. That way you know you didn't miss anything. All right. And then we can combine these. 3 times 3 is 9. M cubed and m gives me m to the 4th. I'll do the other one now, plus, well, there's no more m's, so I know it's just an m, but 3 times 15, I will take away that plus, because it is a negative 15m. Sweet. All right, let's do the second one. Second one in green. So negative 2, so we've got a plus a negative 2m squared times 3m, and a negative 2m squared times negative 5. And it looks like I might want to move this last part over so that we can stay lined up. But it's going to be all still tacked on. Whoops. Get purple. Jeez. Sorry, guys. This is where using colors kind of hinders instead of helps, but that's okay. 3m minus 5. So now I've got this green one. I'm going back to the green one. So I've written it out. Oh, and there should be a plus sign in there. So I've got negative 6m cubed, right? 2 times 3 is negative 6m m cubed. And then over here we've got plus negative 2 times negative 5 is going to be positive 10m squared. Now I'll do the last one. This one's pretty simple because it's just a 4, right? So I get 4 times, let's do 4 times 3m, and 4 times negative 5. We end up with plus 12m minus 20. Alright, and now I've got this huge string of red, green, blue monomials, but I know I've tackled them all because I have 3 terms here and 2 terms here, so I should have a total of 3 times 2, or 1, 2, 3, 4, 5, 6 terms, right? If I know each one is actually being multiplied, I can maybe count it that way. And then I just combined any like terms. So I've got 9m to the 4th minus 15m, 3rd, 2nd. Okay, I've got 2 m's. I can see that, but it looks like everything else is just a singleton. So let's do 9m to the 4th, see, minus 6m to the 3rd, plus 10m squared. Ooh, somebody caught me. This should have been an m cubed. M cubed. So we should have 2. Yeah. JK, JK. So that makes this instead negative 21. Negative 21m cubed plus 10m squared plus 12m minus 20. Should that have been squared? No. Nope, that's definitely what it is. Okay, cool. Sorry about that, guys. That second term, you're probably all wondering, why is it single? What happened there? It's because Miss K forgot the cubed part. So right here, Miss K forgot the cubed in that second distribution, which ended up giving us a combined negative 21m squared. Happens sometimes. Oh well. Alrighty. Moving right along. So now we've got in this next problem 3 things being multiplied together, but again, nothing's changed, right? Associative property, if you remember way back way, associative property says we can do whichever ones we want first. So I can multiply the binomial times the binomial. I can multiply the monomial to either one of the binomials and then do the last one. What I don't want to do is distribute the monomial to all of them, right? You only want to distribute if the monomial sits in front of a parentheses, right? That's how those products worked. If you see something like this, 3m cubed times 3m minus 5, that is where we would distribute. Here with double parentheses, we don't want to distribute over the whole thing. That's multiplying too many times. So let's start with these two, because why not? You can choose whichever ones you want, but I'm going to start with 2x squared times x plus 1. And we'll worry about the x minus 3 later. Alright, distribute. 2x squared times x, 2x cubed, 2x squared minus 1, 2x squared. Now I can go ahead and multiply it by the x minus 3. And when you do that, you go to 1 by 1, so you can multiply the, or I guess we'll rewrite this as we've been doing. So 2x cubed times x minus 3 plus 2x squared times x minus 3. And then we'll tackle each one as a monomial. 2x cubed gives me 2x to the 4th and negative 6x cubed. Here, got 2x cubed minus 6x squared. And now I've got a couple like terms. So I can go over here. 2x to the fourth is just a singleton. He's all by himself. These two middle terms combined, a negative 6 and a positive 2, to give me a negative 4x cubed. And then a last negative 6x squared. And we're done. You would have found the exact same thing had you multiplied the two binomials first and then the monomial. Or even 2x squared times x minus 3 and then times x plus 1. Remember, multiplication is very commutative. You can do, associative. You can multiply them in any order that you choose. Any two can come first. Alright, go ahead and try this one now. Try this binomial times binomial all by yourself. And use any method you want, right? Use any organizational thing you want. But remember, it's just distribution property. So go ahead and try it out, pause the video, give yourself some time, and then come back when you are ready. Okay, so I hope you've had some time to try this out. Let's go ahead and do it ourselves right now. So I've got these two to multiply, right? So I'm going to multiply this first monomial, m to the fourth, m times 4, plus 3m plus 1, minus 5 times 3m plus 1, and then we'll multiply each monomial. So 12m squared plus 4m. Over here we've got negative 15m minus 5. And then in the middle we've got some like terms. This becomes negative, 11? And so we've got 12m squared minus 11 minus 5. Awesome possum. Sweet. Cool, so by now that should be a little more fluid, right? No matter how many you have, just distribute out that first polynomial into monomials. Let's do another one. This one, something fun's going to happen, but maybe you've seen this before, maybe you know what's going to happen here, but let's multiply it out like we didn't know what was going to happen. Let's pretend it's any other polynomial or any other binomial times a binomial. So I'm going to start with the p and the p being multiplied out, so p times p minus 7 plus 7 times p minus 7. So I broke it up into monomials, right? And I'm going to distribute those guys. So I get p squared minus 7p plus 7p minus 49. Right, and then I have some like terms. But what happens when I take care of these like terms? Well, I have p squared that doesn't do anything. But what happens when I have negative 7p and positive 7p? Ah, that's right, they cancel each other out, so I have no more p's. So I'm just left with p squared minus 49. So it ends up becoming another binomial. In all of our other cases, we ended up getting stuff like trinomials, even 1, 2, 3, 4, 5 termed polynomials. Sometimes you'll end up with a binomial again. This is when you factor it. It's called difference of squares. Oops. Yeah, I still went red. Of squares. If you've heard it before, it's kind of the backwards version. This would be called the difference of squares, and then you'd go back to here. But that's more chapter 6, just in case you were wondering. But this is one of our special cases, so you'll see this a lot in chapter 6. Something that happens like this. And notice it happens when you have the same things, but opposite signs. So let's go ahead and try that. Let's see if it works with this one too. See if it works with more than just p plus 7p minus 7. We'll start by distributing, right? So 6x times 6x minus 4 plus 4 times 6x minus 4, right? We end up with 36x squared minus 24x. Here we've got plus 24x minus 16. And it did look like it happened again. Those middle terms canceled out. You get 36x squared minus 16. We ended up with a binomial. Cool. If you can remember that shortcut, you want to maybe take that shortcut and not actually multiply it out. Good luck to you, as long as you remember it correctly, right? Tricks are always fine in math, as long as you know they're proven to be true. If you remember this is difference of squares, you can make that jump. Just make sure you do it correctly, right? If you're going to remember the tricks Make sure you know how the tricks work. Otherwise, you can just straight up multiply them like monomial times monomial, or monomial to monomial. Awesome. If you're going to do that, remember that we're going to talk about something that's slightly different now. It's a polynomial squared, okay? So if you have any questions before now, you need to pause the video, get them answered, and then we will move on to polynomials squared. Okay. Alright, so one of the last things we're going to talk about is the square of a polynomial. Now, sometimes you'll see it looks like this. Usually we'll talk about binomials, sometimes we'll talk about trinomials, this also works for monomials, but remember, what does square mean? What is the square of something? If I were to say 2 squared, talked about this in 5.1, what does it mean? What is a square? Well, that means 2 times itself, right? 2 times itself once. So 2 instances of the same thing. So when I have x squared, right, that's the same thing as x times x, right? So here, what does m plus 7 squared mean? The same thing. M plus 7 times m plus 7. M plus 7 times m plus 7. And if we rewrite it that way, then all of a sudden we have a binomial times a binomial again, and we can just continue the problem as we've seen. So these guys really aren't that special. You just have to remember that something squared is something times itself. So let's go ahead and do that. We have m times m plus 7 and 7 times m plus 7. So I've distributed this guy here and then that guy there. And now I'll simplify it out. So I get m squared plus 7m and 7m plus 49. Combine some like terms. Now be careful, I have 2 instances of 7m here, so this is not going to cancel. This is not what we were just talking about with difference of squares. This is just multiplication, right? So this is m squared plus 14m plus 49. That would be the multiplication of m plus 7 squared. Alrighty. Now it's very, very important to note that this is not the distribution rule. Okay, and I know I've been saying everything is about distribution property. There's a reason one's called distribution property and one's called the distribution exponent rule. Okay, so if we look back up here, you cannot distribute a square to an addition. Okay, when you have multiple terms, you cannot do that. In fact, that's when God starts to kill kittens. Okay, every time you do that, the God kills the kittens. Okay, don't make God kill kittens. Just don't do it. So make sure you do not distribute. That only works. Distribution only works for division and multiplication. Okay, it only works for these 2 instances. These 2 instances you can actually distribute. You'd never, ever, ever want to distribute on something like this. Okay, that's not legal. You can't do that. As soon as you see a plus sign or a subtraction sign, it no longer works. Instead, just remember that something squared is something times itself, and then multiply. I'm telling you to remember less. Like, remember less stuff, right? So make sure you always just stick with your same multiplication basics and just remember that squared is something times itself. So let's try out p minus 5 squared. Now that we know it's not going to be p squared minus 25, right? We're not going to distribute the 2. We're just going to rewrite it as p minus 5 times p minus 5. Alright, and then we'll go ahead and multiply. So I can rewrite this as p times p minus 5 plus minus, or I should say minus 5. Minus 5 times p minus 5. So I break up one of them into monomials, and I get p squared minus 5p minus 5p plus 25, right? So I've got p squared minus 5p and plus 25. Combine some like terms, you end up with p squared minus 10p plus 25. And that's our final answer. Notice that if we had done the distribution thing, we would have said, yeah, it's p squared minus 25, right? P squared minus 25, which not only is not even true, right? It's not not anywhere close to the answer. You're missing an entire term. You're missing an entire term. Can you imagine if you were missing an entire body part? That would be very painful. So don't miss entire terms, right? The reason that we don't distribute is because we miss out on things. Also, we end up with the wrong sign on 25, right? So don't do that. Make sure you always, always, always distribute or write it as something times itself, and then continue what you've been doing this whole time. All right, go ahead and try it with this one right here. I know it's got multiple variables, but that shouldn't scare you right now, right? Because you've got so much practice with everything else that looks crazy. This follows the exact same rule. Go ahead and try it and square that, square that binomial for me. Square that binomial. Pause the video if you need some time. Okay, so I hope you paused the video and had some time to try this out yourself. If not, and you need more time, please go ahead and pause it. But we're going to rewrite this as, let's use a different color, 2p plus 3v times 2p plus 3v. Right? So we'll rewrite it as that. Oops. And then we'll split it up via monomials. So 2p times 2p plus 3v plus 3v times 2p plus 3v. Right, so I'm just, again, splitting up the monomial. Each one gets it. That binomial becomes two monomials. It has a lot of the same stuff, but that doesn't matter, right? I'm just splitting up that first one into monomials. Now I'll multiply each one, so I'll distribute again. 4p squared plus 6pv, right? When I have two different variables, I don't multiply them, I don't actually achieve something new by multiplying them together. I just rewrite them as p times v, right? Do the same thing over here. Plus 6vp. And lastly, I get 9v squared. Now, if you remember way back when we were first talking about polynomials in 5.2, we talked about writing things in descending alphabetical order. The reason that that's a common courtesy, the reason you want to do that is because you may not recognize that these are actually alike terms, right? If I wrote these both in alphabetical order, this would be 6pv plus 6pv, right? That way it's instantly recognizable that they are in fact like terms. If you didn't do that, that's okay, but sometimes, or actually most of the time, it's easier to recognize like terms when things are all written in the same order. So because of that, we end up with 4p squared plus 12pv plus 9v squared as our final trinomial. It's our final trinomial. Awesome. Let's try one more just to really hammer that home, right? We're not going to say it's 9r squared minus 25s squared because that's distributing and we don't want to kill any kittens. So let's do 3r minus 5s times 3r minus 5s. All right. In other words, we're going to multiply each one of these as a monomial. Right, so we'll multiply the 3r to the second binomial, and we'll multiply the minus 5s to the second binomial. It's not ss, it's 5s. All right, we get 9r squared minus 15rs minus 15. And again, I know it's got s first, but I want to write it in alphabetical order, QRS. So it'd be 15rs plus 25s squared. And then the reason I did that is now I can see that I have two negative 15r's, and so I end up with 9r squared minus 30rs plus 25s squared as a final answer, right? That's what I end up with. Awesome. All right, if you have any questions about the squared, please ask them now, because we're going to go on to a little bit higher powers, which isn't much different, but I want to make sure that really hits home. Okay, do not distribute. Just don't do it. Okay. With higher powers, it's the same thing. It's the same exact thing. Never, ever, ever are you allowed to distribute that power. So you can't distribute a third, you can't distribute a 15th, you can't distribute x to the 45th. You can't do that. Okay, you just can't. In other words, just remember what it means. If you have something like x plus y cubed, then you're going to need to rewrite it as x plus y times x plus y times x plus y. It's 3 instances of x plus y. That's what it means. And then just like when we had a problem where we were multiplying 3 things earlier, you simply multiply 2 of them and then multiply the other one. Okay, but what we're not going to do is say that x plus y cubed is equal to x cubed plus y cubed. That is not the case, and I'm going to show you why. So let's multiply this out, see what we actually get. We'll start with x plus y times x plus y. Whether I'm doing the first two or the last two is really up to you. It really doesn't matter because they're all the same. I end up getting, let's see, x times x is x squared. That's kind of confusing. So we'll do x times x plus y plus y times x plus y. I end up getting x squared plus xy. And yes, again, this is y times x, but I'm going to write it in alphabetical order. xy plus y squared. And this first one ends up being x squared plus 2xy plus y squared. Alright, now I'm going to take that and I'm going to go back up here and I'm going to multiply it by another x plus y. And I think I'm going to put that first because then, let's do it in blue, x plus y. Because then I'm multiplying 2 things into a trinomial instead of 3 things into a binomial, but really it would be the same either way. So I'm just going to do it this way. Plus y squared. Awesome. And then we distribute it out. So x times x squared would give me x cubed. X times 2xy would be plus 2x squared y. X times, so I'm just multiplying this x into everything, x, and x. X plus y squared would be plus xy squared. Now I'll do the y. Y, and y, oh, y. I get x squared y, oops, plus x squared y, plus 2xy squared plus y cubed. And when I look closely, none of these are actually alike terms. Actually, no, I take that back. So not many of these, I should say, are like terms. X cubed, definitely the only one we got. So x cubed. And then we have an x squared y, an x squared y, and an x squared y. Plus x squared y, I'm sorry. I have 2 of them and then 1 more, so 3x squared y. Let's see, how many? I've got an xy squared and an xy squared, 2xy squared, so plus 3xy squared. And then lastly, I've got a y cubed. So plus y cubed. Alright. If I had just, oh, love, goodness. Okay, if I had just said that it was x cubed plus y cubed, then I'd be missing out on 2 whole terms this time. So every time you increase power and you do that, you make that mistake, you're missing out on 1 more term. In the first one, we would have missed 1 term. Here we would have missed 2 terms. If we were doing x plus y to the 4th, we'd miss 3 whole terms. So the higher up you go, the more of an offense it actually is. So please, please, please make sure you do not multiply by distributing an exponent to an addition or a subtraction. Okay. Alright, cool. Will I ask you to probably do x plus y to the 3rd on a test? Probably not, but you would be fully capable of it. Actually, I take that back. I might do that. I might. Because it's the same thing no matter what, right? It's just the same thing over and over again. Distributing a monomial over and over and over again. So I might ask you to do it on the test. If you have any questions at all about that, please pause now because we're going to dive back into those polynomial functions we were talking about last time and how we multiply those. And before we get there, I want to make sure you guys can multiply just regular old polynomials. Okay, so last thing we're going to talk about today is multiplying polynomial functions. Remember, a function is just a fancy equation. It's not a special equation, or sorry, a fancy polynomial. It's not a special polynomial, it's just a fancy polynomial. So a fancy polynomial where it's got f of x and g of x. Now, when we write the multiplication of polynomial functions, this is how we write it. fg of x. fg of x. We do not write f times g of x. We never write this. Because I wholeheartedly agree that that looks like f of g of x, right? That would be stupid if we both wrote it this way. So we do not write it like this, okay? Never once do you put a dot. That also doesn't mean fgx, right? The parentheses indicate that x is the variable here. X is the variable in your function. f times g is fg. And it's okay to say fg of x. Just don't say fgx. Alright, just with addition and subtraction, it means that we're just multiplying the functions together. When you multiply, fun fact, the domain is the intersection of the two. That probably will not pop up on a test or anything, but that's what happens. So example 4.1, we have this function, 3x plus 4, and we have this other function, 2x squared plus x. We need to find the multiplications of two said functions and then evaluate that at -1. And we just did this with addition and subtraction. So I'm hoping you can remember all the way back to last class. If not, though, that's okay. Let's talk about it. So we've got fg of x. That's going to be the same thing as f of x times g of x. And in order to do that, we just plug in what we know about f of x and g of x. So I know f of x is 3x plus 4. And I know g of x is 2x squared plus x. And now it just looks like what we did up here. So we're going to just multiply from here on out. Once you've plugged in your functions, it is nothing new. It is just a polynomial equation, or just a polynomial multiplication now. So we can start by distributing that first monomial to the binomial, right? So 3x times 2x squared plus x. And then we'll do the second one, plus 4 times 2x squared plus x. And then we'll tackle them one at a time. So multiply that, you get 6x cubed, right? Add those x's together, you get 3 times 2, which is 6. X times x squared is x cubed. Then we'll do the other one, plus 3 doesn't really have a, it's 3 times 1, so it's just 3. But 2x's is an x squared. Do the same thing over here for the other monomial, plus, let's see, just a 4 multiplying in, you've got 8x squared. And then just a 4 multiplying in, you got plus 4x. Now we can combine some like terms. We end up with these two guys in the middle, so we end up with 6x cubed plus 11x, because I've got 3 x's and 8 x's. I'm so sorry, 11x squared, right? I've got 3x squareds and 8x squareds, plus a 4x on the end. And this is my new function. This is the function fg of x. It's my function fg of x. 6x cubed plus 11x squared plus x to the 4th. Awesome. The only other thing we need to do is now evaluate this function at -1. So we're going to take f of g, the one we just found, f times g, right, f times g, and we're going to plug in -1, because that's what this little symbol means. It means take -1, plug it into the function you're calling f times g. Cool. So I will do that. 6 times -1 cubed. Notice the negative is in the parentheses because that's part of the question, not part of the function, right? And then plus 11 times -1 squared plus 4 times, oh no, I'm running out of room. Oh, okay, well, we'll try that again. We'll write a little small. 11 times -1 squared plus 4 times -1. Okay, cool. Now I'm going to go very slowly. I'm going to tackle those exponents first, right? So -1 cubed is -1. So 6 times -1. -1 squared is +1, so plus 11 times 1. And then we don't have any squareds there, so we'll just keep it as 4 times -1. All right, now I can do the multiplication. -6 plus 11 minus 4. -6 minus 11, or -6 plus 11 is a +5. Minus 4 is equal to 1. Oops. So we get it evaluated at -1. F times g of -1 is equal to 1. Oops. not of x, right? Because of x is the one that still has x in it. F of g of negative 1 is equal to 1. Ta-da! Alright, cool. And so remember that functions aren't really all that different. If it's already been established that it's a function, you don't need to worry about its domain and range. Most but not all of the polynomials that we will be dealing with will be functions, right? We've seen some cases where they're not. But the only thing different about them is you can actually evaluate them because they are equations, not just expressions. Remember, expressions don't have an equal sign. So that's kind of where that comes in. We can actually figure out a number after we go through all this multiplying nonsense, right? All right, cool. So we talked a lot about multiplication today, but remember, the entire section breaks down into distributive property and then combine like terms. That is the entire section. The only other thing you may want to remember is not to kill kittens, right? Do not kill kittens. If you have any questions at all, make sure you get them answered. Otherwise, you may begin your homework.